Hello, Deepa Mathur, Lecturer Instrumentation, GPC KOTA. Continuing with a discussion on basic opamp circuits for the subject Signal Conditioning IE308 for final year instrumentation students. We're going to deal with subtractor today. We're going to learn how we're going to subtract two signals by using operational amplifiers. So here you can see we have two voltages, V1 and V2. We are going to use exactly the same circuit that we have studied before, inverting amplifier system. You can see here same feedback resistance, input voltage, negative terminal, same thing, nothing to get confused. Even this op-amp is in the same manner, RF, R2. Only difference here is we are having two inputs here. Let's go step by step without getting confused. So let's consider op-amp number 1. Output here, nothing to be confused. We already know the answer. RF divided by R1 into V1 with a minus sign. So here the output we are having is minus V1 into RF by R1. That's what I've written here. Output of op-amp 1 minus V1 into RF by R1. No issues there. Now let's come to the second op-amp. Second op-amp, you can see we've got one input coming in from here and one input coming in from here. So you got to be careful that you add this as well as this. Okay. So let's take the simple one. Let's take the simple portion here. Just this much. Here it is RF divided by R2 into V2 with a minus sign. Okay. So that's what I've written here. You can see minus of RF by R2 into V2. This one. We got this. Okay, but we've got one signal coming in from here. We got to add what is the signal that we're getting in from here. So the signal that is coming here is again RF divided by R3 multiplied by the voltage obtained here with a minus sign. So what is that? Minus sign because of the inverting terminal multiplied by RF divided by R3 here, RF by R3 multiplied by whatever is the input voltage. Like here we multiplied it by V2. Here we are going to multiply by the output obtained from the first op-amp. That is minus V1 into RF by R1. Okay. So it's like this. V0 becomes equal to, just taking the minus sign inside. In the previous slide we saw here, there was this minus sign here. I'm just multiplying it to this here, not here, this only for this bracket, it's not for this bracket. Because here we have already given a minus sign separately, and for this we are having a minus sign separately. Both of them are going into the inverting terminals, so both of them are having minus signs, but the output of the first op-amp already has a minus sign here, so this minus you have to multiply with this minus. So this will become positive and this will continue to remain negative. Going to the next slide. Here I've multiplied it and this became positive and this continued to remain negative. So V1 into RF by R3 into RF by R1 minus of RF by R2 into V2. If we are going to assume that all the resistances are equal, then they would all get cancelled and you would be left out with V0 is equal to V1 minus V2. Very simple. So we've been able to subtract both the signals at the output. So we've got an output which is the subtracted value of both the voltages, input voltages. That's subtractor. Thank you.